What is up, guys? It's Jacob here and welcome to your second Arduino tutorial. Today we're actually going to start by plugging in our board and writing our first program. Basically, we're going to start out just by making sure everything is working right. So we have the Arduino development environment little thing here opened up, and basically we're going to actually write our first program and write it to the board today. And this is just going to confirm that we know how to write our programs to the board from here on out. Because if you're unable to write just a simple program to your board, then you're going to have a really hard time writing, complex programs in the future that you just don't have time to troubleshoot like issues with communications of the board. You really just want to focus on your code. So we're going to make sure that everything works in this video, and we're going to check it out right here. So I want to start out by saying that in the last video I kind of mentioned that Arduino is written in C or C++. Now a lot of people actually ask me this. A lot of people, I've seen it online, they ask what language does Arduino use, and I'm actually going to kind of discuss that right now, because even though I did say it was C++, it kind of is, but it kind of isn't. So let me just kind of explain what that is real quick, just so you guys know what language it is that you guys need to learn, or what it is that you guys are actually using for this. So Arduino uses what's called a machine language. It's actually not C++. What it is it's kind of just a language that's been kind of developed around this whole platform, this Arduino platform. It's kind of specific to Arduino. However, a lot of it is C. You can use a lot of C stuff in here. Stuff like variables, where you have integers, doubles, constants, loops like that, your for loops, your while loops, stuff like that. That'll all work in here. Your if statements, it's all the same. But there's some things like the setup function that's very specific to the Arduino, sort of like if you were to write a normal C program, you'd have your int main function, and your main function is what would run like in a console program. Here we have our setup function, then our loop, which is what goes over and over and over again, and it loops. And you have things like, let's just say the function, let's just say digital write, so digit. So like this would not be recognized in the C language. You can't just use this in C++. But what this is it's a function written for Arduino that the developers have made, and it's just a function to write a pin on the board to make it either high or low or whatever. So it's a function specific to the Arduino platform, but it's not actually C. So it is sort of C++. You can use C++ code in here, but it is also Arduino specific code. So it's machine code, but it is C++. Now I do want to let you guys know that when it comes down to the very technical bare bone basics, it is 100% C++. This actually compiles in C++. It's got a compiler built in. When you actually verify it, the code, and upload it to your board, it compiles it. Then it uploads it to your board. Now, all those little functions, like I showed you, that digital write function, this is actually defined in another file somewhere that Arduino has already written for you, which is great. That means we don't have to write a huge C++ function to make this digital write pin work. But this, I mean, when you get to the bare bone technical basics, this actually is a C++ file. So there's going to be like a digital write.c++ and a digital write.h file to make this function actually work within this program. But so it is C++, but it's machine code language. So that's basically it, the demystification of what language it is. But yeah, if you're gonna learn anything, you're gonna be learning C++ for this. That's the language that it does use. But so that's it for the language. So I'm gonna start out by saying that from all my tutorials, or for at least for most of them that I'm running right now, I'm going to use the Arduino Mega 2560. So this board is actually a Chinese off-brand. It's just a cheap make, one that I bought on eBay for a couple bucks. I bought it for like 15, 20 bucks, I don't know. Normally these would probably cost you 40, 50 bucks. Now, I would not recommend you buy the Japanese ones if this is your first time doing it, because you may have issues with drivers. We can see here that there's two big chips. There's two chips on here, main chips. There's the huge processor here that we can see, and then there's the little chip over here, which is the USB to serial adapter, and that's what communicates between the USB port and the actual processor. The problem with that is if they use a different type of a serial adapter, then you have problems with drivers, and it's not directly compatible with the Arduino software that we see here, and it just makes things a lot more difficult. And if it's your first time, it can make things unenjoyable and more of a task to deal with than it's worth, and it'll completely ruin the experience for you. So if you're gonna do it, grab an original Arduino board made by Arduino themselves, and pay the 40-50 bucks for it, because it will save you a lot of time and it will make the experience more enjoyable for you. And they're built with a little bit more quality and whatnot. But you can see here that we have there's a little barrel jack. I'm running off USB power right now, but there's a little barrel jack down here that we have that can supply, I don't know, I think it's anywhere from like 5 to 12 or 18 volts or something like that. Don't take my word on it like that, because you might blow it up. But I know for sure it goes up to 12 volts. And we see that there's a little 5-volt regulator down here. That guy actually gets pretty toasty while it's running. It converts that high voltage input that you may put like 12 volts or whatever down to 5 volts, and powers it all with 5 volt, logic voltage, the TTL. So that's what that guy does. So that's pretty much it for this board that I'm running. So now let's just go ahead and plug it. Now that we have it plugged in, we can see the blue power light and everything is on, and it's just kind of sitting here in standby waiting for us. So what we're going to do is we're just going to go ahead and, now that we have it plugged in here, we're going to show you on here, we have, when we go to tools and then we go to board, you want to make sure you have your board selected. We're going to go to the Arduino Mega 2560 for my case, because that's the exact board I'm using. And then we're going to go ahead and use the communication 7 or whatever port that pops up. That's the port that you want to use. You want to use COM, whatever that pops up. Usually it recognizes it. If there's more than one option, just kind of go through them down the list till you have one that actually works. But this is the actual USB port that you're going to be using. It may not always be the same number, but regardless, just select the one that works. You'll find it. Usually there's only one, but sometimes there may be multiple ones, and just keep going until you find the one that works. So now that you've got those selected, it knows exactly where to communicate to your board. So we're just going to actually write a simple program to make sure it works. So the very most simplest program that you can possibly write for this is the blinking LED. So we're going to go ahead and write that just to test everything out and make sure it works properly. So again, this is the C language. We're going to use the int function, which stands for integer, and this is going to create a variable, and this is exactly how you would do it in the C++ language. So we're going to create a variable called LED, and so this LED variable is an integer, which means it's going to be a whole number. So we're going to set LED equal to pin 13. So I'm just going to say 13. Now this doesn't mean pin 13 or anything. This is just a variable 13. This can mean anything. This can mean 13 milliseconds. This can mean 13 seconds. It could mean 13 pin 13. It can mean anything. We haven't defined it, or we haven't used it for any function or anything yet. It's just a variable called LED, which is equal to the integer value of 13. So now what I'm going to do is I'm going to use the Arduino function called pin mode. We're going to say PIN capital MODE. Now what this is going to do is it's going to allow us to define a pin's function, whether it's an input or an output. So we're going to say pin mode LED, comma. Okay, so what this is saying is pin mode LED, the LED pin, and then we're going to go ahead and say comma capital OUT PUT for output. OUT PUT, and come on, which means it's going to define it as an output. So then we go ahead and close that little bracket and put a semicolon. Just like any C language, you're going to end it with the semicolon right there. So we have pin mode, and then this would be the number of the pin, the actual pin number, which up here is, we have LED defined as pin 13. And then this is the output function right here, which means that is declaring pin 13 as an output. Now on most Arduino boards, pin 13 has a built-in LED, so that's why we're going to use pin 13. Now you're going, Jacob, why wouldn't you just go ahead and go 13 right here, 13? Well, would that work? Yes, it would, because we're going to actually do the same thing. It's going to write to pin 13 and make it pin 13 an output. But why would we want to say go through the trouble of making this variable appear and say 13 and then put LED down here instead of 13? Okay, and I'll show you that in just a second. Let me just keep going a little bit more and I'll show you why that makes sense. But it does make sense. So now what we're going to do is we're going to do something called the digital write function. We're going to say digital write, capital W. And what we're going to do is we're going to go ahead and say, again, the pin number on the pin that you want to write, and then you're going to say how you want to write it. So in our case, we're going to write it high, which means we're going to give a 5-volt output signal, a digital 1. It's a digital function, which means it's either going to be 1 or 0. It's going to be 0 or 5 volts on the output. And what we're doing is we're saying the LED pin, we're going to write that to high. So we're going to give it a 5-volt output. It's going to turn that pin on. That's what this function here is going to do. So now it may be a little bit more apparent why we use the LED function here, the LED, what do you call it, variable, instead of writing 13. So let's just say I put 13 here, and I put 13 here. Now let's just say I have a really, really long code that's like, I don't know, 100 lines long. And throughout the whole code, I reference this pin 13, right? But now let's say, my project changed a little bit, and I need to use pin 13 for something else. But I want to move this to pin 11. So now I want to use pin 11 instead of pin 13. Well, if I have pin 13 written everywhere in here, I have to go back through my code, and I have to change that to pin 11. I have to go here, and I have to go to pin 11, and then I have to go throughout my entire code, which may be 100 lines long, maybe even longer, and change all those 13s to 11. Whereas, let's just say I put the word LED here, and I put the word, LED here. These are variables. And now if I have LED defined throughout my entire code, and it's defined up here as 13, and I want to change it to 11, all I have to do is just backspace it, boom, put 11, and now that changes all the functions in the entire code to pin 11 instead of 13. So that's why you would use a variable. It can change very easily. It allows you to make changes to your code very quickly, and it allows it makes things easier to read too. I know it's the LED pin instead of going, what the hell is 13? So now what we have is something that's saying, okay, pin 13 is an output, and we're going to turn that LED on. So now what I'm going to go ahead and do is I'm going to use the delay function, D-E-L-A-Y. And in this basically delays it. It just gives the code a pause. So it actually just stops whatever it's doing and just pauses for however long you want it to. Now this is measured in milliseconds. So what we're going to do is I'm going to say, delay 1000, which means delay 1000 milliseconds. Now 1000 milliseconds is equal to 1 second. So if we delay 1 second, and then what we're going to do is we're going to go ahead and do the same thing. We're going to digital write it again. So I'm just going to, I'm going to go ahead and copy this right here. Oh, I keep doing that. I'm going to go ahead and copy this. And down here, instead of writing it high, I'm going to go ahead and write it low now. Okay? And then I'm going to go ahead and copy this one more time, and I'm going to go ahead and paste it right down here. Oop. So, for some reason, my copy function isn't working properly. There it goes. Alright, so let me kind of just give you a quick little rundown of this real quick, and then we'll see what this looks like. So, we're writing the output high, okay, or we're taking this pin mode and we're declaring pin 13, right, 13 as an output, which is the pin with our LED on it. Then we're turning it high, so we're turning that pin on. We're giving it 5-volt output. Then what we're going to do is we're going to wait 1000 milliseconds. So we're going to wait 1 second. So it's going to turn on for 1 second. Then we're going to turn it off after 1 second has passed. After we turn it off, we're going to wait 1 more second. So it's going to be off for a second. Now this is the loop function, which means once it has finished this and it's all done running this code, it's going to go back up to the top and start where it, where it started. So it's going to turn high, so it's going to turn on, wait a second, turn off, wait a second, then it's going to go back to the top and turn back on, wait a second. So it's just going to turn on and off continuously forever, and it's going to wait a second. So let's go ahead and upload it, and now we can see that we've already had an error. So let's go ahead and see what that error is. So a function defined is not allowed before this token. So what we are missing actually is this little bracket. We can see that at some point I deleted the closing bracket on my void setup code, my void setup function. So now let's go ahead and just try that one more time. And it's actually compiling it just like any other C language. You're going to have to compile the sketch before you upload it. It found no errors this time, and it says it's done uploading. Now, again, this video is kind of just also helping you to make sure that you can upload a code to your board. If it were to not give you, if it did not give you this done uploading message and it gave you a communication error, or it said it timed out or it couldn't communicate with the board, then you may have a driver issue, or you may not have the correct board or port selected up here, and you just may want to switch through those till you get the right one. If it still doesn't work, then it's probably a driver issue, and that can be very specific to whatever your problem is. If you do have issues with that, go ahead and head over to my website, thehackhub.com, and ask a question there, and I can help you with it on your specific situation there. But if it does not show done uploading, then don't continue on to any of these tutorials. Fix that problem first, because if you cannot successfully upload just a simple code like this to your board, then you're definitely not going to be able to upload codes further down in the other tutorials. So make sure that you get this to work first. And your board should have a flashing LED just like we see right here. So the board has a flashing LED on pin 13. That's the only pin that has an LED built into it. Besides the communication pins, we'll get into that later. That has nothing to do with this right now. But pin 13, we can see the LED is blinking on and off for 1 second. So the code was successfully written, and everything works great. It works fine. So we've successfully written our first code to our Arduino board. So congratulations, guys. You are now troopers, and you guys can continue to the next tutorial where who knows what in the world we will explain. But it'll be really cool, and you guys have done fantastic. So that's pretty much it for this one, guys. I just kind of wanted to explain the basics of how this all breaks down, what everything does. But that's pretty much it for this. I hope to see you guys in the next tutorial, and like always, guys, have a good one.